Hi everybody, welcome back to my YouTube channel. Today I want to make a video about something that I thought and I found very important to talk about. That's it, alright? These are the questions that I want to focus on because it's amazing, honestly, it's amazing. Okay, so I actually didn't know, not that I didn't know, I didn't focus on knowing it, okay? I didn't care to know if there was a difference between surface area and normal area, but clearly there's a difference. Normal area, obviously, that's a vector quantity. Surface area, that's a scalar quantity. But something I wanted to primarily focus on is compare these two questions. It says, when is magnetic flux maximum? The answer is not A. It's not A. It is B, when the surface area is perpendicular to the magnetic field. Now, if you have thought so far, you've thought that surface area was essentially the same thing as normal area, you'd be wrong. Okay, I would be wrong as well because I thought that, okay? But look at this one. It says, when is magnetic flux through a surface maximum? The answer would be A, when the normal area is parallel to the magnetic field. Now, this is what I want to focus on today. I wanted to focus on the difference between what's normal area and what's surface area. Guys, you see this, okay? The direction of the magnetic field is into the page, so I made you guys a hole, so it'd be like this, okay? So into the page, it'd be like this. Like something like this, okay? It's into the page, okay? But you have to obviously look at the page right like this way. But it is essentially into the page, like this, into the page. Now, what is normal area and what's surface area? You see this thing, it's a rectangle or barely a rectangle, and I have, okay, this portion is, where my magnetic field, is working on this, let's say, rectangle. Look, the size of this window, the size of this rectangle, okay, is the surface area. And the surface area is just this, okay? Like this is, how do I say it? Like, see it this way. It doesn't have, it's not, I suppose, three-dimensional. It's two-dimensional, okay? So it has the length, it has the width. That's it. It's not 3D, okay? It's not three-dimensional where you're like, okay, but it's like going this way. No, it's just like this, just like that, all right? But so it says surface area is the size of the window. It's essentially just the size of that window, okay? And if I were to compare it like, my pen is like this into the page, okay? It's into the page, all right? If it's into the page, what is it? How is it in with respect to the surface area? Well, if you go and look at it, you'd see that this is the way to go for having maximum magnetic flux this way, okay? Magnetic flux this way is the maximum, okay? Because, look, guys, it's sort of like your nose, okay? Your face, your nose, okay? The direction your nose is pointing right now, that's the normal, okay? That normal area, normal vector, okay? Normal area, okay? Guys, so the normal area is which way the window is facing. The way the window is facing this way, it's obviously, I can't draw something like this. But imagine this window, it's obviously facing this way or it's facing this way, okay? It's either facing upward or downward, okay? We know it's like this, upward or downward. Either way, the it is parallel to the magnetic field. So either way, AB, hold on, AB cosine theta, this angle between them is going to be 0 because it's parallel. The normal area is parallel. Like I told you, it's this way. It's up and down, going up and down. Not this way, but up and down, like this way, okay? Exactly like this way. And the surface area is essentially like a two-dimensional thing. It's nothing more, length, width, that's it. So it's not gonna be pointing this way or that way. It's just the size of the window. And if we are taking into account the size of the window, and let's say the area vector is this way. It could be going downward, going upward. It's facing upward and downward. So I don't really care. But let's, for now, focus on, let's say downward, because I want to not confuse it with the magnetic field. The magnetic field is going downward. The normal area doesn't matter, going up and down. It's pointing downward, pointing upward, same thing. It's like a line. It is a line. And so Now imagine the surface area, which is the size of the window, this rectangle that you see. Okay. Guys, take it as two-dimensional. I'm going to show you this way. Take it as two-dimensional. How is the magnetic field with respect to this paper, let's say, or with respect to the rectangle? It's perpendicular. It's perpendicular. There's a 90 degree, if you can see it like this. There's a 90 degree. It's perpendicular. So let's go back to the questions. If you cannot understand, which I highly doubt, like with the explanation that I gave, I'm sure that inshallah most of you guys will understand. But if you didn't understand, just memorize it. You don't have time left, so just memorize it. So it says, when is the magnetic flux maximum? Well, when the surface area is parallel to the magnetic field, absolutely not. It is when it's perpendicular to the magnetic field. I just showed you right now. Look at that. Like this. Take it at that. This is the magnetic field. Look at they're perpendicular. Okay. When is it zero? When it is parallel. Yeah, when it's parallel, it's zero. So I said perpendicular, it's maximum. Parallel, it's minimum. When is the magnetic flux through the surface maximum? That talks about normal, guys. It says, look at this option. This surface area is parallel. Like I told you, parallel is zero. Parallel is zero. Hold on, I have a paper with me. Yep, parallel is zero. Anyways, I don't need the paper. But parallel is zero, so that's not the one to go. It is when it is parallel to the magnetic field, because like I told you, it's an up and down thing. It's like a line, let's say line, from the roof going to the floor. It's there. It's parallel to the magnetic field, which is into the page. Guys, that's it. That's pretty much it. Inshallah, you guys understood, because I actually did the very best of my ability to be able to explain this. Okay, bye-bye.